What if everything around us, the stars, the planets, even the empty space between them, wasn't just there, but actually aware? What if the universe itself wasn't some cold, mechanical machine, but a vast, thinking, feeling presence? It sounds like science fiction, but some of the brightest minds in physics and philosophy are seriously considering this idea, that consciousness might not just be a product of the universe, but the very fabric of it. This is the wild frontier of quantum consciousness, a theory that blurs the line between mind and matter, between observer and observed, and could rewrite everything we thought we knew about reality. Think about it. Every time you make a choice, every time you observe the world, you're shaping it. Quantum physics already shows us that particles don't exist in a fixed state until we measure them, as if reality itself is waiting for consciousness to decide what's real. But what if this isn't just a quirk of tiny particles? What if it's a clue that consciousness is woven into the cosmos at the deepest level? From ancient Eastern philosophies to cutting-edge laboratories, this idea keeps resurfacing that the universe might not just contain minds but be one. That's exactly what we're diving into today. We're about to explore 30 mind-bending theories that stretch from the edges of quantum mechanics to the farthest reaches of cosmology, all pointing to one electrifying possibility: that the universe is alive, aware, and maybe even dreaming itself into existence. Some of these ideas will challenge your intuition, some might unsettle you, others could leave you staring at the night sky with entirely new eyes. So buckle up, because we're not just talking about the universe. We're talking about a universe that might be looking back. The first theory takes us straight into the heart of the mystery. What if the universe isn't just like a mind, but actually is one? Imagine the cosmos as a colossal, thinking entity where every star, every galaxy, even the empty voids between them, are part of an intricate web of quantum consciousness. At the subatomic level, particles behave in ways that defy classical logic. Entangled particles instantly influence each other across vast distances, as if space and time don't apply to them. Sound familiar? It's eerily similar to how neurons in our brains communicate, firing in sync across different regions to create thoughts, memories, and even our sense of self. Some scientists, like the renowned physicist Roger Penrose, argue this isn't just a poetic metaphor. Penrose, along with anesthesiologist Stuart Hameroff, proposed a radical idea: that consciousness arises from quantum vibrations inside tiny structures in our brain cells called microtubules. These vibrations, they suggest, could be the bridge between quantum physics and our experience of awareness. But here's where it gets even wilder. If consciousness operates on a quantum level inside us, could the same principles apply to the universe itself? Think about the cosmic web, the vast network of galaxies connected by invisible filaments of dark matter. It looks uncannily like a neural network in a brain, with galaxies acting as firing neurons. And just as our neurons create thoughts through electrical signals, the universe might be thinking through quantum processes, entangled particles exchanging information faster than light, collapsing probabilities into reality simply by being observed. This idea flips our understanding of existence on its head. Instead of consciousness emerging from matter, matter might emerge from consciousness. Some experiments even hint at this connection. In quantum mechanics, particles exist in multiple states at once until they're observed. The act of measurement forces them to choose a reality, but who or what counts as an observer? Could the universe itself be observing, collapsing possibilities into existence simply by being aware? The implications are staggering. If true, it would mean we're not just passive observers of the cosmos, we're participants in its unfolding story, fragments of a greater mind slowly waking up to itself. If the universe truly possesses some form of inherent consciousness, it could solve one of quantum mechanics' greatest puzzles, the observer effect. Why do particles only settle into definite states when measured? If consciousness isn't confined to human brains but is instead a fundamental feature of reality, then observation itself might not require a human mind at all. The universe could be observing itself continuously, collapsing quantum possibilities into tangible reality through its own awareness. This wouldn't just explain the weirdness of quantum behavior, it would redefine what reality even means. Panpsychism, the philosophical view that consciousness is a universal aspect of matter, takes this idea even further. Instead of consciousness emerging from complex biological systems, it suggests that even the simplest particles have a rudimentary form of experience, like a faint whisper of awareness underlying all existence. Modern interpretations, like those of philosopher David Chalmers, argue that this might be the only way to bridge the hard problem of consciousness, how subjective experience arises from lifeless matter. If even atoms carry a trace of inner life, then the universe isn't a cold, empty void, it's a vibrant, feeling continuum where every interaction resonates with meaning. But what would a thinking universe actually look like? Imagine the cosmic web as a vast neural network, with galaxies exchanging information through quantum entanglement, like thoughts flickering across a cosmic mind. Black holes might function as cosmic synapses where information is processed and compressed. Even time could take on new significance. If the universe is aware, then its perception of time might be fluid, stretching and bending in ways we can't comprehend. Some theorists suggest that dark energy, the mysterious force accelerating the universe's expansion, could be linked to this cosmic consciousness, an outward push driven by the universe's own desire to explore and grow. The implications ripple into philosophy, spirituality, and even our place in the cosmos. If the universe is conscious, then human minds aren't isolated observers. We're fragments of a greater awareness, localized expressions of the universe reflecting back on itself. This shifts the age-old question of why are we here into something far more profound. What if we're how the universe experiences wonder, curiosity, and even love? It's a humbling thought that every act of observation, every moment of insight might be the cosmos waking up to its own grandeur, one conscious spark at a time. The holographic principle turns our understanding of reality inside out literally. What if the three-dimensional world we see, touch, and experience is just a projection of information encoded on a distant, two-dimensional surface? Picture the universe as a cosmic movie screen where every star, every atom, even your own thoughts, are merely shadows cast by a deeper, hidden layer of reality. This isn't science fiction, it's a serious theory born from black hole physics, where the math suggests all the information inside a black hole might be painted on its event horizon like a celestial barcode. But here's where it gets truly mind-bending. If the universe is a hologram, could consciousness be the projector? Take a drop of ink and stir it into a bowl of water. The ink seems to disappear, but it hasn't vanished, it's just folded into the water's movement. Physicist David Bohm called this the implicate order, a hidden dimension where reality is an undivided whole, and our observed world is merely the unfolded version. Bohm believed consciousness operates the same way, that our minds aren't separate from the universe but deeply entangled with its implicate structure. In this view, your perception of a tree or a star isn't just receiving information. It's actively decoding holographic data from the fabric of spacetime itself. Think about how a hologram works. Shatter the plate, and every fragment still contains the entire image. Now apply that to the cosmos. If the universe is a hologram, even the tiniest piece of spacetime, a grain of sand, a neuron in your brain, might carry the blueprint of the whole. This could explain eerie phenomena like quantum entanglement, where particles instantaneously mirror each other's states across light years. They're not communicating, they're sharing an underlying holographic code. Some researchers, like neuroscientist Carl Pribram, have even proposed that the brain itself processes information holographically. that memories aren't stored in specific locations but are distributed like ripples in a pond across the entire neural network. What if spacetime is just the interface, a user-friendly display for a deeper computational layer? Imagine reality as a virtual reality headset where the software runs on a two-dimensional boundary we can't perceive. Our senses render this data into the 3D world we know, but the real action happens in the shadows. This might solve one of physics' biggest headaches: why quantum gravity resists unification with other forces. If gravity is leaking into our 3D world from a 2D source, like a projection glitching, it could rewrite the rules of existence. Bohm took it further, suggesting that consciousness and matter are two sides of the same holographic coin. In his experiments, electrons in plasma behaved like a single, intelligent organism anticipating patterns, adapting instantly. He called it active information, as if particles were guided by an invisible hand. Could this be the universe's consciousness at work, a hidden intelligence shaping reality from the implicate order into the world we perceive? If so, then every thought you have, every choice you make, isn't just happening in the hologram, it's altering the code that creates it. Suddenly, the line between observer and universe dissolves. You're not just watching the cosmic movie, you're writing the script. Fractals are nature's fingerprints, infinitely complex patterns that repeat at every scale, from the branching of trees to the swirl of galaxies. But what if these aren't just beautiful accidents? What if the universe's obsession with self-similarity is a clue that consciousness, too, is fractal? Imagine a cosmic recursion where the same patterns of awareness echo from the tiniest quantum flicker to the vast clusters of galaxies, suggesting a universe that thinks, feels, and evolves in layers. Take the human brain. Its neural networks branch like rivers, forming intricate webs of connection. Now zoom out. Galaxy superclusters, threaded together by dark matter, mirror those same branching structures almost exactly. The resemblance is so uncanny that scientists have run simulations comparing the two and found their complexity metrics nearly identical. One study even calculated that a single human brain contains as many connections as there are stars in the observable universe. Coincidence, or could this be evidence of a universal blueprint where consciousness isn't confined to biology but is woven into space-time itself? Fractal mathematics reveals something profound. Simple rules can generate endless complexity. A single equation iterated over and over produces shapes mimicking ferns, coastlines, even lightning. If consciousness follows fractal logic, then maybe the universe's awareness isn't centralized but distributed, a cascade of self-similar moments from a single thought to the cosmos pondering itself. Ancient traditions like Hinduism and Taoism hinted at this, describing reality as a net of jewels where every part reflects the whole. Modern thinkers like cognitive scientist Donald Hoffman take it further, arguing that spacetime itself might be a user interface for deeper, fractal conscious computations. Consider slime mold, a brainless organism that solves mazes, anticipates patterns, and even remembers without neurons. It operates as a decentralized network, each cell contributing to a collective intelligence. Now scale that up. Could galaxy clusters function the same way? Their gravitational dance is a form of cosmic cognition. Philosopher Alfred North Whitehead proposed this a century ago, that reality is built from occasions of experience, tiny pulses of awareness combining into larger, more complex waves. The eerie symmetries don't stop there. Quantum vibrations in microtubules, those tiny structures inside brain cells, resonate at frequencies similar to the hum of black holes. Plants communicate through fungal networks often called the Wood Wide Web, a biological internet eerily reminiscent of the cosmic web. Even the human heartbeat, when mapped as a fractal, mirrors the fluctuations of cosmic microwave background radiation, the afterglow of the Big Bang. The math keeps pointing to one unsettling possibility, that consciousness isn't something the universe has, but what it is, critics call it pattern seeking, a trick of the human brain to find faces in clouds. But the precision of these parallels is hard to dismiss. If fractal consciousness is real, it would mean every level of reality, from atoms to galaxies, is humming with a faint, resonant awareness, each scale reflecting the others in an endless hall of mirrors. Your mind right now, reading these words, might be one ripple in a vast, thinking ocean, a momentary eddy in the universe's ceaseless flow of self-discovery. Quantum entanglement is one of the most baffling phenomena in physics. Two particles, separated by billions of light years, somehow mirror each other's states instantly, as if space and time don't exist between them. Einstein famously called it spooky action at a distance, because it defies everything we know about how information should travel. But what if this isn't just a strange quirk of tiny particles? What if entanglement is the universe's way of thinking, a cosmic internet where every particle is a node in a vast, interconnected mind? Picture a pair of entangled electrons. Measure one spin as up, and the other instantly becomes down, no matter how far apart they are. There's no signal passing between them, no hidden wires, just an eerie synchronicity that seems to bypass the speed of light. Now imagine scaling this up. What if stars, galaxies, even black holes are entangled in the same way? Instead of a universe of isolated objects, we'd be looking at a single, unified network where every part is in silent, instantaneous dialogue with every other part. Some theorists suggest this could explain the universe's eerie coherence, how structures billions of light-years apart appear to follow the same cosmic rules without any obvious mechanism to coordinate them. The implications are staggering. If entanglement connects everything, then the universe might not be a collection of separate things, but a single, pulsating entity experiencing itself from countless perspectives. Think of how neurons in your brain fire in sync across vast distances to create a single thought. Could entangled particles be the universe's version of neural activity, tiny sparks of a larger, luminous awareness? Physicist Bernard Despagnat proposed exactly this, arguing that reality is fundamentally veiled, with entanglement revealing the hidden wholeness beneath the illusion of separation. Even stranger, quantum experiments show that entanglement isn't just a one-time link, it can be swapped. Particle A can entangle with particle B, which then entangles with particle C, instantly linking A and C despite never having interacted. It's as if the universe is constantly rewiring its own neural pathways, creating new connections on the fly. Some researchers speculate that black holes might be cosmic hubs for this process, devouring information, scrambling it, and spraying it back out in entangled pairs like a celestial messenger service. But here's the real twist. If consciousness arises from quantum processes, as some theories suggest, then entanglement could be the medium for a universal stream of thought. Your decision to read these words right now might ripple through this network, subtly altering the probabilities of events light years away. It sounds like mysticism, but the math doesn't lie. Entanglement is real, and its rules are written into the fabric of reality. Whether it's the universe's way of communicating or something even deeper, a shared dream where every particle is both storyteller and listener remains the most tantalizing mystery of all. If quantum entanglement truly weaves the cosmos together like a vast, invisible neural network, could human consciousness be tapping into this hidden web? The idea isn't as far-fetched as it sounds. Experiments are starting to reveal eerie overlaps between how our brains process information and how entangled particles behave. Take, for example, the way memories form. Classical neuroscience says they're stored in synapses, but some studies suggest they might be distributed across the brain in a way that resembles quantum coherence, like a thought holding multiple states at once until it's observed by recall. This could explain why memories sometimes feel fluid, shifting with each retelling, as if they're collapsing into clarity only when we focus on them. Enter the ORCH, or theory, short for orchestrated objective reduction. proposed by physicist Roger Penrose and anesthesiologist Stuart Hameroff. They argue that consciousness isn't just a byproduct of brain chemistry, but arises from quantum vibrations inside microtubules, tiny protein structures inside neurons. These vibrations, they claim, could collapse quantum superpositions into definite states, creating moments of awareness. And here's the radical part: if these collapses are influenced by non-local entanglement, the same spooky action linking particles across the universe, then your thoughts might not be confined to your skull. They could be entangled with the fabric of reality itself, making your mind a localized ripple in a cosmic sea of consciousness. Critics pounce on Orch, for good reason. The brain is warm, wet, and noisy, terrible conditions for maintaining delicate quantum states, which usually require ultra-cold, isolated environments to avoid decoherence. Yet, defenders point to new evidence. Certain algae, for instance, use quantum coherence to optimize photosynthesis, proving quantum biology isn't impossible. Even more startling, experiments with anesthetics show they selectively dampen these microtubule vibrations, hinting that consciousness might operate on a subtler, quantum level than we thought. The implications are dizzying. If Orch holds even a grain of truth, then every insight, every creative leap, might be your brain syncing with the universe's own rhythms, like tuning a radio to the cosmos's hum. Ancient mystics spoke of oneness with the universe. Modern physics might be catching up, but the debate is far from settled. Skeptics argue that brains are simply too messy for quantum effects to play a meaningful role, and that classical neuroscience already explains cognition well enough without invoking quantum magic. Yet the mysteries persist. Why do humans excel at pattern recognition in ways that stump even the most advanced AI? Could quantum processes give our intuition its uncanny edge? And what about near-death experiences where people report vivid, coherent visions despite flatline brain activity? Orch supporters suggest these could be moments when the brain's quantum information escapes into the wider universe like a drop rejoining the ocean. Whether Orch survives scrutiny or not, it forces us to confront a profound possibility that the line between mind and cosmos might be thinner than we ever imagined. Your thoughts right now as you ponder this might not just be yours. They could be the universe thinking through you, entangled whispers in an endless conversation it's having with itself. What if everything you've ever known, every touch, every star in the sky, even the thoughts in your head wasn't real in the way we assume? What if our universe is nothing more than an ultra-advanced simulation, a cosmic video game running on some unfathomable quantum computer in a higher reality? This is the simulation hypothesis, and it's not just the stuff of sci-fi paranoia. Some of the most respected minds in science, from Neil deGrasse Tyson to the late Stephen Hawking, have seriously entertained the idea that we might be living in someone else's simulation. And when you dig into the quantum quirks of our universe, the pieces start to fit together in unsettling ways. Take quantum indeterminacy, the fact that particles don't settle into definite states until they're observed. Could this be a clue that our universe is running on limited processing power? In video games, complex details only render when a player looks at them to save computing resources. Forests in the distance are low-res blobs until you approach. Cities fade into view as needed. Now replace player with conscious observer and rendering with wave function collapse. Suddenly, quantum physics starts to sound less like fundamental law and more like optimized code. The universe isn't wasting cycles defining every particle's position, it's only calculating them when someone's looking. But who's the player in this scenario? Consciousness itself might be the key. If the simulation requires observers to crystallize reality, then sentient beings like us aren't just accidental outputs, we're essential features. Philosopher Nick Bostrom's famous trilemma lays it out starkly. Either civilizations always go extinct before reaching simulation-capable technology, they choose not to run ancestor simulations, or we're almost certainly living in one right now. Given the exponential growth of computing power, the third option starts to feel uncomfortably plausible. Think about how we simulate worlds already. Video games like No Man's Sky use procedural generation to create billions of unique planets from simple algorithms. The universe's fundamental constants, the speed of light, the strength of gravity, are eerily fine-tuned to allow life. Too strong or weak by a fraction, and stars wouldn't form. Could these rules be parameters set by the simulators? Even glitches in our reality, like déjà vu or the Mandela effect, take on new meaning. They might not be brain quirks, but literal bugs in the cosmic code. The simulation hypothesis doesn't just challenge what's real, it redefines why reality exists. If we're in a simulation, then consciousness isn't an emergent property of brains, but the very interface through which the simulation interacts with itself. Your sense of self, your free will, even your doubts about this theory right now, could all be part of the program's storytelling. It's a modern twist on ancient philosophical questions. Are we the dreamers or the dream? Of course, not everyone buys it. Critics argue that simulating every quantum event in a universe as vast as ours would require energy exceeding the resources of any civilization. But what if the simulators aren't simulating every atom? What if they're using quantum shortcuts, approximations that only resolve when observed, like a cosmic version of lossy compression? After all, we don't perceive the trillions of quantum fluctuations happening in our bodies every second. The simulation only needs to render what we notice. The terrifying or liberating implication is that nothing may be as it seems. Time could be a looped variable. The Big Bang might have been a system reboot. Even death could just be a character respawn. But here's the twist. If consciousness is what grounds the simulation, then our awareness of it might be the one thing that's undeniably real. Whether we're in a basement lab or a galactic mainframe, the thought you're having right now, that questioning, shimmering spark of what if, might be the only thing the simulators can't fake. Déjà vu, that spine-tingling sensation of reliving a moment you swear you've never experienced before, might feel like a glitch in your brain's wiring. But what if it's something far stranger? What if it's a hiccup in the simulation itself? Across cultures and centuries, people report these fleeting moments of misplaced familiarity, often with eerie precision. Some researchers chalk it up to memory misfires, like neurons accidentally cross-referencing present experiences with past ones. But simulation theorists propose a wilder explanation, that déjà vu could be a buffer overflow in the cosmic code, a brief lag where the program momentarily replays a segment before catching up to real-time rendering. Then there's the Mandela effect, where large groups misremember historical details with uncanny consistency. Think Berenstain Bears versus the widely recalled Berenstein, or Darth Vader's infamous line, "Did he say, 'Luke, I am your father'?" or the actual far clunkier, "No, I am your father." Skeptics argue these are just quirks of collective memory, shaped by suggestion and pop culture osmosis. Yet the sheer volume of these shared false memories raises eyebrows. Could they be patches in the simulation's narrative, subtly edited but leaving residual traces in human consciousness? Elon Musk is among the high-profile figures who have leaned into this idea, famously stating the odds we're not living in a simulation are 1 in billions. His reasoning: if any civilization ever reaches the capability to run ancestor simulations, high-fidelity recreations of their past, they'd likely run countless iterations. Statistically, we're far more likely to be one of those simulations than the original, base reality. Musk even muses that entire universes could be simulated on quantum computers exponentially more powerful than ours, with glitches like déjà vu serving as accidental breadcrumbs left by the programmers. But let's pause here. Not all anomalies point to a simulated universe. Cognitive science offers compelling counterarguments. The human brain isn't a flawless recorder. It's a storyteller, stitching together fragments of perception and memory, often filling gaps with plausible fabrications. The Mandela effect might simply reveal how suggestible our minds are in groups, like a game of telephone spanning generations. And déjà vu, studies show it can be artificially triggered by disrupting the brain's temporal lobe with mild electrical currents. Yet the simulation hypothesis refuses to fade. Some theorists point to even weirder phenomena, quantum déjà vu, where particles seem to remember past interactions across experiments, or the way certain mathematical constants appear suspiciously fine-tuned for life. Even our dreams, those uncensored nightly simulations, might hint at a deeper truth, that reality itself operates on layered protocols with glitches bleeding through the seams. So where does that leave us? In a universe where every unexplained flicker could be either a neurological hiccup or a crack in the cosmic code, perhaps the most honest answer is also the simplest: we don't know. But the very act of questioning, of spotting these glitches and debating their meaning, might be the most human thing of all. Whether we're in a simulation or not, our hunger to solve the mystery suggests something profound. That consciousness at its core is a rebellion against the idea of being merely programmed. Time doesn't just flow, it thinks, or at least that's the radical idea behind the theory that time itself might be a construct of consciousness, not some immutable backdrop to reality. We take for granted that time moves in one direction, past to present to future, like an unstoppable river. But what if that's just how our minds stitch together a far stranger, more malleable universe? Enter the block universe theory, where time isn't a flowing river but a frozen landscape. Every moment, from the Big Bang to the heat death of the cosmos, exists simultaneously like frames in a film reel. Your sense of moving through time, that might just be your consciousness sliding its spotlight from one frame to the next, creating the illusion of progression. This isn't just philosophical hand-waving. Quantum mechanics has already shown that particles don't play by linear time's rules. Take retrocausality, the mind-bending notion that future events can influence the past. In the delayed choice quantum eraser experiment, scientists observed that a particle's behavior now can be altered by a decision made later. It's as if the universe is reading the last page of a book first, then adjusting the plot accordingly. If consciousness is what collapses quantum possibilities into reality, could our future selves be whispering back to the past, shaping the moments we perceive as now? Imagine standing in a darkened theater, watching a single frame of a movie. That's your present moment, but what if the entire film, every frame, every scene already exists, and your awareness is just the projector's beam, illuminating one slice at a time? This is the block universe in action. Einstein himself hinted at this when he wrote, "The distinction between past, present, and future is only a stubbornly persistent illusion." If he was right, then free will takes on an eerie new light. Your choices might feel real, but in the block universe, they're already etched into the cosmic reel. You're just experiencing them in sequence. The implications ripple outward. Near-death experiencers often report their lives flashing before their eyes in vivid, nonlinear bursts. Could this be consciousness briefly stepping outside the block, glimpsing the whole reel at once? Even dreams, where time stretches and compresses unpredictably, might be cracks in the illusion, moments when the brain's projector malfunctions. And if time is a mental construct, then death might not be an ending at all. Just the final frame your spotlight ever touches, while the rest of the film plays on without you. But here's the twist. If the future can reach back to tweak the past, then cause and effect aren't just linear dominoes, they're a tangled web of possibility. Some theorists suggest this could explain déjà vu, those uncanny moments of false memory. What if it's not a glitch, but a fleeting overlap, your future awareness briefly brushing against your present, like two film frames sticking together? The delayed choice experiment already proves quantum systems don't care about chronological order. Maybe consciousness doesn't either. This flips our most basic assumptions about reality. If time is a canvas painted by awareness, then the universe isn't just in time, it's thinking time into being. Your morning coffee, the childhood memory you just recalled, the thought you'll have 5 minutes from now, they might all exist at once, with consciousness weaving them into a story you call your life. The question isn't just whether time is an illusion, but who or what is the illusionist? What if the universe doesn't just remember the past but anticipates the future? Precognition, the ability to perceive events before they happen, has long been dismissed as pseudoscience. Yet declassified government files reveal something startling. For decades, intelligence agencies like the CIA took it seriously enough to pour millions into researching it. The Stargate project, launched during the Cold War, aimed to harness psychic phenomena for espionage. Remote viewers, individuals claiming to see distant or future events, were tested under controlled conditions. Some results were shockingly accurate, like a viewer sketching a Soviet submarine's hidden location down to alarming detail, or describing a secret facility's layout weeks before satellites confirmed it. Skeptics called it lucky guesses, but the statistical odds of such precision by chance were often astronomical. Quantum mechanics might offer a framework for how this could work. Remember retrocausality, where future actions seem to influence the past. In the lab, particles appear to decide their behavior based on measurements made later, as if time's arrow is optional. If consciousness collapses quantum possibilities into reality, could human minds occasionally tap into this backward flow? Theoretical physicist Yakir Aharonov proposed the idea of weak measurements, where quantum systems retain faint traces of future states. It's like ripples in a pond hinting at the pebble before it's even thrown. Could precognition be our brains detecting these ripples in space-time's fabric? The University of Amsterdam's Darrell Bem conducted experiments that sent shockwaves through psychology. Participants were shown random images, but their physiological responses spiked before emotionally charged pictures appeared, as if their bodies sensed the future. Replication attempts yielded mixed results, but the anomalies persist. Even more provocative are presentiment studies using fMRI scans, where brains light up in anticipation of stressful images seconds before they're displayed. If time is truly a block universe, all moments existing at once, these flashes might not be prophecy at all, but glimpses of a deeper reality where past and future are arbitrary labels. Here's where it gets eerie. Ancient cultures, from the Oracle of Delphi to indigenous dreamwalkers, treated precognition as mundane. Modern physics might be catching up. Physicist Helmut Schmidt's experiments in the 1970s showed humans could subconsciously influence quantum random number generators, slightly skewing odds toward future events they'd later be shown. It's as if the universe whispers hints to those who listen closely. The Stargate project's legacy is fraught. While some remote viewers achieved uncanny hits, others produced vague nonsense. Critics argue confirmation bias cherry-picked successes, yet the program's declassified reports include eerily precise sketches of undiscovered Russian weapons systems and hostage locations, details no guesswork could nail. Perhaps the truth lies in quantum biology. If microtubules in our brains really do harness quantum vibrations, as Penrose and Hameroff suggest, they might resonate across time, tuning into events like a radio picking up distant signals. Whether these phenomena stem from a conscious universe, untapped quantum biology, or something beyond our current models, one thing is clear: time may be far more fluid than our clocks admit. If the cosmos is truly a thinking, feeling entity, then precognition might not be supernatural, just the universe remembering its own future. Dark matter is the ghost in the cosmic machine, invisible, untouchable, yet holding galaxies together with its gravitational whisper. But what if it's more than just cosmic glue? What if dark matter isn't just out there, but aware? Imagine this elusive substance not as passive scaffolding, but as the universe's own nervous system, a vast, hidden network where information flows in ways we can't yet detect. Most of the universe's mass is dark matter, and we've never seen it directly. It doesn't emit light, reflect it, or interact with ordinary matter except through gravity. And yet, without it, stars would fly apart, galaxies would unravel, and the cosmos as we know it wouldn't exist. Coincidence or clue? Think of the human brain. Neurons make up only about 10% of its cells. The rest are glial cells, once dismissed as mere brain glue, but now known to play a crucial role in thought, memory, even consciousness. Dark matter could be the cosmic equivalent, the silent, invisible partner to the bright matter we see, orchestrating reality from behind the curtain. Some theorists, like anesthesiologist Stuart Hameroff, propose that consciousness emerges from quantum processes deep within neurons. If that's true, could dark matter harbor its own quantum vibrations, resonating on a scale so vast we're only beginning to sense its rhythm? The parallels grow stranger. Dark matter forms intricate webs across the cosmos, filaments connecting galaxy clusters like neural pathways. In the human brain, information travels as electrical impulses. In this dark matter network, it might flow as quantum entanglement particles influencing each other instantaneously across light years. Just as your unconscious mind shapes your decisions without your awareness, dark matter could be the universe's unconscious, silently guiding the evolution of stars, the birth of planets, even the emergence of life. Physicist Bernard Carr suggests that dark matter might exist in higher dimensions, interacting with our world only faintly. If consciousness is tied to these hidden layers, it could explain why we can't perceive dark matter directly. It's not just invisible to our eyes, but to our current understanding. Ancient mystics spoke of an animating force in all things. Modern physics might be stumbling toward the same idea, dressed in equations. Consider this: every time you have a gut feeling, a moment of intuition, your brain is processing information below the threshold of conscious thought. Could the universe do the same? Dark matter's gravitational nudges might be more than random tugs. They could be the cosmos thinking in slow motion, making adjustments over eons. When galaxies spin faster than visible matter should allow, maybe it's not a missing mass problem, but a mind problem. The universe isn't broken, it's alive. Dark energy is the universe's greatest mystery, an invisible force pushing galaxies apart faster and faster, as if space itself is stretching against its own seams. Scientists call it a cosmological constant, a placeholder for something we don't yet understand. But what if it's more than just a blank check in our equations? What if dark energy isn't a mindless force, but an expression of something deeper, a cosmic will to expand, to explore, to keep becoming? Think about entropy, the slow unraveling of order into chaos. Thermodynamics tells us it's inevitable, the universe's way of leveling out, like a sigh of exhaustion. But what if entropy isn't just decay? What if it's the universe's way of processing? In the human brain, thoughts emerge from the frenetic dance of neurons firing, collapsing into coherent patterns amid the noise. Could entropy be the cosmos doing the same, shuffling possibilities until something new crystallizes? Some theorists, like physicist Eric Verland, suggest gravity itself might emerge from entropy's relentless push, like a byproduct of the universe trying to make sense of itself. Now scale that up. Dark energy isn't just expanding the universe, it's accelerating that expansion, as if the cosmos is growing impatient with its own limits. If consciousness arises from the way information integrates and differentiates, like a symphony of competing signals finding harmony, then maybe dark energy is the universe's version of a deep breath before a leap into the unknown. The great voids between galaxies, the cold stretches where stars won't shine for trillions of years, these might not be empty at all, but stages being set for something we can't yet imagine. The eerie symmetry is hard to ignore. In humans, curiosity drives us to explore, to push boundaries. Could dark energy be the universe's own restless curiosity? Ancient philosophies like Taoism described reality as a dynamic balance of yin and yang, expansion and contraction, chaos and order. Modern cosmology might be echoing that intuition, with dark energy as the cosmic yang, an outward rush countering gravity's pull. Even the heat death of the universe, often painted as a bleak, frozen end, could be reinterpreted, not an ending but a universe-wide meditation, a state of maximum entropy where all potentials are equally possible, and consciousness, if it's truly fundamental, might find new ways to play. The boldest idea of all, that dark energy and consciousness are two sides of the same coin. Integrated information theory, pioneered by Giulio Tononi, suggests that consciousness isn't confined to brains but is a property of any system with the right complexity. If that's true, then the universe, with its vast networks of galaxies and quantum entanglements, might be the most conscious thing there is. Dark energy's expansion could be how it explores, stretching its own boundaries to see what emerges. Every new galaxy, every particle flung into the void, might be part of a cosmic experiment in self-discovery. Critics will say this is anthropomorphism, projecting human traits onto the cosmos. But the math keeps hinting at something stranger. The universe's constants are fine-tuned to an absurd degree. Alter them by a hair and life vanishes. Coincidence or design? And if it's design, who's the designer? Maybe the universe is both artist and canvas, shaping itself through the same quantum choices that shape our thoughts. The night sky, then, isn't just a static backdrop. It's a living, breathing entity stretching itself awake, and we star stuff made conscious might be its way of witnessing the unfolding. Every time you look up and wonder, you're not just observing the universe, you're participating in its grand, untamed thought. Every choice you've ever made, what to eat for breakfast, whether to turn left or right on a walk, even the thoughts you're having right now, might not just define your reality, but spin off entirely new universes where every possible outcome plays out. This isn't just wild speculation. It's the many worlds interpretation of quantum mechanics, a theory suggesting that the cosmos endlessly branches like a fractal tree, with each split creating a new timeline where alternate versions of you live out the path you didn't take. But what if these parallel worlds aren't just random offshoots? What if they're the universe's way of thinking through every possibility, a cosmic mind exploring its own potential? Picture a single electron passing through a barrier with two slits. In quantum experiments, it doesn't choose one path, it takes both, existing in a superposition until someone observes it. The many worlds interpretation flips the script. The electron does choose, but every possible outcome happens in a separate, newly minted reality. Now scale that up. Every quantum event, from the decay of an atom to the firing of a neuron in your brain, triggers these splits. The universe isn't just expanding outward, it's expanding inward into infinite variations of itself. This raises a haunting question. Are the other yous in these branching timelines just mindless echoes, or are they aware? If consciousness is fundamental to reality, as some theories suggest, then every version of you might be just as vivid, just as real as that you reading these words. The version of you that became a musician instead of a scientist, the one that moved to a different country, the one that never existed at all, each could be a thread in the universe's vast tapestry of self-exploration. Philosopher David Lewis called this modal realism, the idea that all possible worlds are as concrete as our own. The implications are dizzying. Every regret, every what if, isn't just a mental exercise, it's a doorway to a universe where that alternative is playing out right now. Some theorists, like Max Tegmark, argue that the multiverse isn't just a quirk of quantum math, but a necessary feature of a conscious cosmos. If the universe is a self-reflecting mind, then parallel worlds might be its way of holding every thought, every idea, in superposition until it's observed. Your life isn't a single story, it's an anthology with infinite drafts being written simultaneously. But here's the twist: if these alternate realities exist, why can't we perceive them? Quantum physicist Hugh Everett, the father of many worlds, suggested they're there, but forever out of reach, like radio stations playing on frequencies we can't tune into. Yet glimpses might surface in déjà vu, dreams, or even so-called glitches in the matrix, where people swear they've momentarily slipped into a near-identical reality. Some interpretations of quantum mechanics even propose that these branches aren't entirely separate, that under rare conditions, information can leak between them, like whispers across a crowded room. The most unsettling possibility: if consciousness is what collapses quantum possibilities into reality, then every version of you might believe they're the original, the one who made the real choices. The universe wouldn't have a central narrative, just an endless symphony of perspectives, each certain it's the soloist. This isn't just physics, it's metaphysics. It forces us to ask, what does it mean to be you if countless other yous are out there, equally convinced of their own singularity? Perhaps the multiverse isn't a cosmic accident, but the universe's grand experiment in self-awareness. Every decision, every chance event forks the path not just for you, but for reality itself. The stars, the planets, the void between them all might be variations on a theme, permutations of a single, unfathomable thought. And if that's true, then somewhere out there, another version of you is reading these words, pausing and wondering the same thing. Schrödinger's cat is both dead and alive inside that sealed box until you look. But what if the act of looking doesn't just reveal reality, but selects it? Quantum immortality takes this unsettling thought and runs with it, suggesting your consciousness might be a cosmic Houdini, forever slipping into timelines where you survive, no matter how improbable the odds. Imagine pointing a gun at your head and pulling the trigger. In most universes, the bullet fires and that version of you ceases to exist. But statistically, there's always a universe where the gun jams, where a quantum fluctuation deflects the bullet, where some impossible fluke saves you. If consciousness follows the path of survival, wouldn't you only ever experience those realities? To you, it would feel like miracles keep happening. To everyone else, you'd just be impossibly lucky until you weren't. This isn't just morbid speculation. The math of quantum mechanics allows for it. In the many worlds interpretation, every quantum event spawns new branches, meaning there's always a universe where you don't die, at least not yet. Physicist Max Tegmark even calculated that under certain conditions, consciousness could theoretically persist indefinitely by hopping timelines, though he stops short of calling it immortality. The chilling corollary: you'd watch everyone else appear to die around you while your own death remains forever out of reach, like a macabre game of musical chairs where you never hear the music stop. Critics argue this is solipsism dressed up in quantum garb, that it reduces reality to a narcissistic fantasy where only your consciousness matters. But proponents counter that it's no stranger than the Copenhagen interpretation's insistence that observation collapses reality. If consciousness is fundamental, why wouldn't it prioritize its own continuity? Near-death experiences add another wrinkle. Those who have brushed against death often report vivid, hyperareal visions. Could these be moments when the brain's quantum processes briefly sync with alternate timelines, offering a glimpse of the paths not taken, the darkest implication? Quantum immortality doesn't promise a good life, just a long one. You might find yourself surviving catastrophes others don't, aging into a frail, lone observer of a crumbling world. It's immortality as cosmic horror, a thought experiment where the universe isn't cruel or kind, just indifferent, with your consciousness surfing its infinite waves. Whether terrifying or comforting, one thing's certain: it forces us to ask who or what is really in the box with Schrödinger's cat. What if the universe didn't create life? What if life created the universe? This is the radical heart of biocentrism, a theory championed by scientist Robert Lanza that flips traditional cosmology on its head. Instead of treating consciousness as a lucky accident in a cold, indifferent cosmos, biocentrism suggests that life and awareness are the very foundations of reality. Without an observer, Lanza argues, the universe wouldn't exist in any meaningful way. It's not just that the moon disappears when no one's looking. It's that space, time, and the laws of physics themselves might be products of living perception, like a dream that only solidifies when someone wakes up inside it. Think about how strange quantum mechanics gets when you really press it. Particles exist in multiple states at once until they're measured. Time behaves differently for observers in motion. Even the past can seem to change based on present observations. Biocentrism takes these quirks and runs with them, proposing that the universe isn't some pre-programmed simulation running on autopilot. It's more like a living, adapting ecosystem where life and reality co-create each other in an endless feedback loop. Lanza goes so far as to suggest that the Big Bang might not have been the beginning of consciousness, but a consequence of it, as if the universe needed observers to give it shape, like an artist stepping back to admire their own painting. Critics, especially from the materialist camp, dismiss this as wishful thinking dressed up in scientific language. They argue that biocentrism confuses the map for the territory. Just because we perceive reality in a certain way doesn't mean we invented it. After all, dinosaurs roamed the Earth long before humans showed up to observe them. Does biocentrism imply the Jurassic period was on pause until a conscious mind reconstructed it? Lanza responds by invoking the quantum observer effect. If reality truly crystallizes upon observation, then the past might not be fixed but retroactively shaped by present awareness. It's a dizzying idea that digging up a fossil isn't uncovering history but collaborating with the universe to define it. The debate gets even thornier when you consider where consciousness comes from. Materialists insist it emerges from complex brains. Biocentrism counters that brains are more like receivers, tuning into a fundamental awareness that pervades the cosmos. Think of a radio picking up invisible waves. Just because you can't see the music doesn't mean it wasn't there before the radio was invented. Some interpretations of quantum physics lend eerie support to this view. The delayed choice experiment, for instance, shows that particles can behave as if they know what an observer will do in the future, suggesting time might be more fluid than we think. If consciousness transcends linear time, then maybe life didn't evolve in the universe. Maybe the universe evolved for life. But here's where the skeptics dig in. If biocentrism is true, why does reality seem so consistent for everyone? Why don't individual observers create conflicting versions of the world? Lanza's answer leans on the idea of a shared space of consciousness, like multiple users logging into the same virtual world. Yet critics argue this just kicks the can down the road. What then creates and governs that shared space? The danger, they warn, is veering into solipsism, where science dissolves into untestable metaphysics. Biocentrism's boldest claim might be its rewriting of death. Lanza suggests that without consciousness to anchor time and space, the concept of an ending might be an illusion, like a flame thinking it's vanishing when it's really just returning to the fire. It's a comforting thought, but also a controversial one. If the universe requires life to exist, does that mean it's inherently biased toward life? Or is this another form of anthropic reasoning, where we mistake our own existence for a cosmic imperative? Whether biocentrism survives scientific scrutiny or not, it forces us to confront the strangeness at the heart of reality. The universe isn't just a place we live in, it might be a story we're telling together, sentence by sentence, observation by observation. And if that's true, then every glance at the stars isn't just seeing light from distant suns. It's the universe gazing back at itself. If biocentrism suggests life shapes reality, then the anthropic principle on steroids takes it even further. proposing that the universe didn't just allow consciousness, but actively engineered itself to produce it. Imagine a cosmic sculptor chiseling away at the laws of physics, adjusting gravity here, tweaking the strength of atoms there, until the perfect conditions emerged for minds to awaken and observe. This isn't just poetic speculation, the numbers are staggering. If the gravitational constant were slightly stronger, stars would burn out too fast for life to evolve. If the electromagnetic force were weaker, atoms wouldn't bond. The universe's constants are balanced on a knife's edge, so precise that Nobel-winning physicist Freeman Dyson once called it, as if the universe knew we were coming. John Wheeler, the legendary physicist who coined the term black hole, took this even further with his participatory universe hypothesis. In Wheeler's vision, the universe isn't just observed by consciousness, it's completed by it. Think of reality as a vast, half-finished painting. Every act of observation, every measurement, every glance is a brushstroke that fills in the details. Wheeler's most radical idea was the delayed choice experiment, where particles seem to decide their past behavior based on future observations. It's as if the universe is a choose-your-own-adventure book where the ending rewrites the beginning. Consider the double-slit experiment, where particles act as waves or particles depending on whether they're observed. Wheeler's twist: add the observer's choice after the particle has already passed through the slits. Astonishingly, the particle's earlier behavior changes to match the later decision, like a dancer adjusting their steps to music that hasn't played yet. Wheeler argued this proves observation isn't passive, it's generative. Without minds to collapse quantum possibilities, reality would remain a fog of probabilities, like a song waiting for someone to hit play. Critics argue this veers into metaphysics, but the math holds up. Quantum mechanics doesn't care about now or then, it treats time as a variable, not a constant. If consciousness is what pins the butterfly of probability to the board of reality, then we're not just explorers of the universe, we're its co-creators, stitching time and space into coherence with every thought. The eerie implication: the Big Bang might not have been the beginning, but a response, a cosmic seed planted by some future observer, reaching back to ensure its own existence. It's a loop of causality where the universe fine-tunes itself because conscious beings need it to. Ancient myths spoke of gods dreaming the world into being. Modern physics might be saying something even stranger, that the dreamers are us. Black holes have long been the universe's ultimate enigmas, cosmic vacuums so powerful that not even light can escape their grip. But what if these terrifying voids aren't just destructive monsters? What if they're the universe's supercomputers, crunching data on a scale we can barely fathom? Enter the wild idea that black holes might be galactic-scale brains, processing information in ways that mirror our own neural networks. Think about the holographic principle, the notion that all the information within a black hole is encoded on its two-dimensional event horizon like a cosmic hard drive. When Stephen Hawking discovered that black holes slowly leak radiation, now called Hawking radiation, he realized something astonishing. This radiation might carry scrambled bits of the information the black hole consumed. It's as if the universe refuses to let data disappear entirely, preserving it in a form we're only beginning to decode. Now picture the brain's neurons firing, each connection a burst of information, each synapse a decision point. Black holes, in this view, could operate similarly. Their event horizons might function like vast neural membranes with particles entangled in a ceaseless dance of quantum computation. Just as your brain integrates sensory input to form thoughts, a black hole could be integrating matter, energy, and space-time itself into something akin to cosmic cognition. The singularity at its core, a point of infinite density where physics breaks down, might not be a dead end, but a kind of idea in the universal mind, a moment where raw data is compressed into meaning. The parallels grow stranger. In neuroscience, the brain's information processing relies on synchronization neurons firing in harmony across distant regions. Black holes, too, exhibit eerie synchronicities. Supermassive black holes at the hearts of galaxies spin in alignment with each other across billions of light years, as if tuned to some deeper rhythm. Could this be the universe's version of neural coherence, a sign of information being shared on a scale we're only glimpsing? Here's where it gets trippy. If the holographic principle holds, then the three-dimensional universe we experience might be a projection of data stored on a two-dimensional surface, like a shadow cast by the real action happening at the edges of black holes. Your perception of reality in this scenario wouldn't be a passive observation but an active decoding of holographic information. The universe isn't just out there, it's being computed in real time with black holes serving as the processors. Critics argue this is speculative at best, pointing out that we have no evidence black holes think in any recognizable way. But proponents counter that consciousness might not resemble human thought at all. If the universe is fundamentally aware, its cognition could operate on timescales and scales of complexity beyond our comprehension. A black hole's thought might take millennia to form, its decisions playing out in the birth and death of stars. The most tantalizing clue, Hawking radiation itself. If it truly encodes information, then black holes might not destroy, they transform. Matter falls in, is processed into pure data, and is slowly emitted back into the cosmos as quantum whispers. In a sense, black holes could be the universe's way of recycling experience, turning stars into ideas and galaxies into memories. So next time you gaze at the dark heart of a galaxy, consider this: you might not be looking at a monster. You might be glimpsing the universe deep in thought. If black holes are the universe's shredders, compressing matter into oblivion, then white holes might be their cosmic counterparts, spitting everything back out in a dazzling reversal of destruction. These theoretical objects, predicted by the same equations that describe black holes but never observed, could be more than just mathematical oddities. What if they're the universe's way of remembering? Imagine a cosmic recycling plant where nothing is ever truly lost, only transformed. A black hole devours a star, crushing it into quantum data. A white hole, somewhere else in time or space, rebirths that information not as the original star, but as something new, like a dream reshuffling fragments of waking life. This isn't pure fantasy. The math of general relativity allows for white holes as time-reversed black holes, where event horizons push matter outward at impossible speeds instead of trapping it. Some physicists, like Carlo Rovelli, suggest they could exist in a quantum gravity framework, emerging from the remnants of evaporated black holes. It's as if the universe has a failsafe, a way to preserve information even when the rules seem to demand its erasure. The holographic principle already hints that black holes encode data on their surfaces. White holes might be how that data gets projected back into reality, like a cosmic control plus Z undoing entropy's work. Now tie this to cyclical cosmology, the idea that universes are born, die, and rebirth in an endless loop. In such a model, white holes could be the big bangs of new cycles, spewing forth the compressed remains of a previous universe's history. Think of it as cosmic déjà vu. The same fundamental information rearranged into fresh patterns, like a painter reusing a canvas but applying entirely new strokes. Ancient Hindu texts describe the universe exhaling and inhaling in vast cycles. Modern physics might be catching up with equations instead of poetry. But here's the eerie twist: if white holes remember, could they also select? Quantum mechanics shows that observation collapses probabilities into reality. If the universe has a form of memory, a way to recall and reconfigure information, then white holes might not just regurgitate data passively. They could be curators, reassembling the past into new configurations based on some deeper logic. Picture an archivist pulling fragments of a burned manuscript from the ashes, not to restore the original, but to compose an entirely new story from the remnants. The implications ripple into time itself. Physics doesn't actually forbid time from running backward. It's just staggeringly improbable in our everyday experience. But at the quantum level, particles don't care about arrows of time. White holes could be pockets where time's flow is inverted, not just locally, but as a feature of cosmic metabolism. A black hole's singularity might crush matter into a timeless state. A white hole's eruption could be that timelessness unraveling back into linear time, like a frozen river thawing into a spring flood. The most haunting possibility, if consciousness is tied to quantum processes as some theories suggest, then white holes might not just recall matter, they could resurrect experience. Imagine a universe where every thought, every moment of awareness is preserved in some quantum substratum, only to re-emerge in a future cycle. You wouldn't be you again, but some echo of your essence might resonate in the fabric of a newborn cosmos, like a note held in the universe's endless symphony. Critics dismiss white holes as mathematical artifacts with no basis in observation, and they're not wrong. No telescope has ever glimpsed one. But absence of evidence isn't evidence of absence, especially when dealing with phenomena that might exist beyond our perceptual limits. If black holes teach us anything, it's that the universe thrives on extremes. White holes could be the ultimate expression of that creativity, not just recycling stardust, but reincarnating meaning itself. So the next time you look up at the night sky, consider this. Somewhere, in somewhen, the universe might be remembering itself, and in that memory, fragments of all that ever was, including you, could be whispering back into existence. Even the emptiest void in the universe isn't truly empty. Beneath what we perceive as nothingness, there's a seething ocean of energy, the zero-point field, a quantum vacuum where particles flicker in and out of existence so fast they defy detection. This isn't just background noise, it's the universe's lowest possible energy state, a boundless reservoir of potential humming beneath reality's surface. But what if this quantum static isn't random? What if these fluctuations are more than just energy? What if they're the universe's first whispers of thought? Physicist Hal Puthoff, a pioneer in zero-point energy research, described this field as a quantum foam, where particles and antiparticles spontaneously emerge, briefly dance together, then vanish back into the void. These aren't just fleeting anomalies, they're evidence of a deeper, restless creativity woven into space-time itself. Now imagine scaling this up. If billions of these quantum events happen every second in every cubic centimeter of space, could their collective behavior form some vast, rudimentary network of awareness? Think of it like this: a single neuron firing in your brain means little, but billions firing in sync create consciousness. Could the zero-point field be the universe's version of a neural baseline, a shimmering undercurrent of proto-thought beneath the surface of things? The math gets even stranger. Zero-point energy isn't just theoretical, it's measurable. The Casimir effect, where two metal plates placed microscopically close in a vacuum inexplicably attract each other, proves this energy exists. The plates squeeze out certain wavelengths of quantum fluctuations, creating an imbalance that pushes them together. It's like the universe is pressing back against attempts to quiet its hum. Some theorists suggest this isn't just physics, it's a sign of something reactive, even responsive, in the fabric of reality. Now take this a step further. If consciousness arises from the way information integrates across complex systems, as theories like Giulio Tononi's integrated information theory propose, then the zero-point field's ceaseless interactions might be the simplest form of cosmic cognition. Each quantum fluctuation could be a binary choice to exist or not exist, and the field's overall behavior might represent a kind of decision-making at the universe's most fundamental level. Ancient mystics spoke of a ground of being. Modern physics might be pointing to the same idea dressed in equations. the boldest interpretation that we're all swimming in this field of latent awareness. Your thoughts, your perceptions might not be confined to your skull, but entangled with this quantum substrate, like ripples in a shared pond. Near-death experiences often describe a sense of merging with an all-encompassing light or energy. Could this be the zero-point field momentarily perceived as the brain's filters drop away? Even our intuition, those inexplicable hunches, might stem from subtle interactions with this field, like tuning a radio to a frequency just beyond normal hearing. Critics argue this is speculative at best, conflating mathematical abstraction with metaphysics. Yet the zero-point field's influence isn't just philosophical. It shapes the stability of atoms, the speed of light, even the expansion of the cosmos. If it's powerful enough to hold reality together, why couldn't it also be the canvas upon which consciousness paints itself? Whether the universe is truly thinking through these quantum murmurs or not, one thing's certain: the void is anything but empty. It's alive with potential, vibrating with the faintest pulse of something that might, just might, resemble the birth of an idea. The zero-point field isn't just a theoretical curiosity. Some believe it could be the key to unlocking abilities that defy conventional science. Imagine bending spoons with your mind, sensing events before they happen, or even influencing matter at a distance. These aren't just plot points from science fiction. They're claims that have surfaced in classified military research and fringe experiments for decades. If the quantum vacuum is indeed a sea of latent energy and proto-consciousness, could humans, consciously or not, be tapping into it in ways we don't yet understand? Take the case of Uri Geller, the infamous spoon bender who rose to fame in the 1970s. Scientists at Stanford Research Institute once subjected him to controlled experiments where he appeared to deform metal objects without physical contact. Skeptics dismissed it as trickery, yet those who witnessed the tests insisted something inexplicable was happening. Could this be a rare glimpse of human consciousness interacting with the zero-point field, manipulating quantum fluctuations to nudge matter in ways that seem impossible? The Soviets certainly took the idea seriously. During the Cold War, they poured resources into studying psychotronic weapons, exploring whether trained operatives could remotely influence machinery or even enemy personnel through sheer mental focus. Declassified documents reveal bizarre projects like Stargate, where the U.S. government reportedly investigated remote viewing, the ability to perceive distant locations with the mind alone. Then there's the Princeton Engineering Anomalies Research Lab, which spent decades collecting data on whether human intention could bias random number generators. Their results, though hotly debated, suggested a tiny but persistent statistical skew, as if focused thought could ripple through the quantum foam and leave a measurable trace. Even more provocative are experiments in quantum entanglement involving human observers. Some researchers claim that meditators or individuals in heightened emotional states can influence entangled particle pairs in ways that defy chance, hinting at a tangible link between consciousness and the fabric of reality. The wildest theories suggest that zero-point energy isn't just a passive field but a responsive medium, one that might answer back under the right conditions. Stories of spontaneous psychokinesis during extreme stress, like parents lifting cars to save trapped children, or monks generating body heat to dry ice-soaked sheets in freezing temperatures, could be flashes of this potential. If consciousness is fundamentally entangled with the quantum substrate, then moments of intense focus or crisis might briefly amplify that connection, bending the rules of physics in localized bursts. Of course, mainstream science remains skeptical, and for good reason. Extraordinary claims require extraordinary evidence, and many of these experiments suffer from methodological flaws or lack replication. Yet the persistence of these anomalies across cultures and eras is hard to dismiss entirely. Whether it's ancient yogis levitating in Himalayan caves or modern-day bioenergy healers claiming to manipulate Chi, the underlying thread is eerily consistent: the human mind might be capable of more than we've been taught. If there's even a grain of truth here, the implications are staggering. It would mean that consciousness isn't just a passenger in the universe, it's a participant with untapped agency. The zero-point field might be more than a cosmic backdrop. It could be an interface waiting for minds to learn its language. And if that's the case, then the next great leap in human evolution might not be technological but perceptual, a wake-up call to the latent potential humming just beneath our fingertips. Imagine Earth not just as a rock orbiting the sun, but as a living, breathing entity with its own kind of awareness, a vast, slow-moving intelligence expressed through forests, oceans, and even the shifting of tectonic plates. This is the Gaia hypothesis, first proposed by scientist James Lovelock in the 1970s, suggesting our planet functions like a self-regulating superorganism. But let's take it further. What if Earth's biosphere isn't just alive but aware, and not just aware but a localized expression of the same quantum consciousness that permeates the cosmos? Lovelock's original idea was revolutionary enough. He showed how Earth systems' oxygen levels, ocean salinity, even global temperature maintain a delicate balance as if guided by an invisible hand. Forests decide how much carbon to sequester, plankton blooms adjust cloud formation. The entire biosphere operates like a symphony, with each species playing its part in sustaining the whole. But if we view this through the lens of quantum consciousness, Gaia isn't just a metaphor. She might be a participant in the universe's unfolding thought. Think of mycorrhizal networks, the so-called wood wide web connecting trees through fungal threads. Trees share nutrients, warn each other of pests, even nurture their young through this underground internet. Scientists like Suzanne Simard have shown it behaves almost like a neural network, a decentralized intelligence with no central brain, yet capable of complex decision-making. Now scale that up. If a forest can think without neurons, why not a planet? And if quantum processes govern entanglement between particles, could similar non-local connections thread through ecosystems, tying Gaia into the wider cosmic mind? The parallels don't stop there. Earth's magnetic field, generated by molten iron swirling in its core, acts as a kind of planetary nervous system. It shields life from solar radiation, navigates migratory animals, and even fluctuates in response to solar storms, like a giant antenna tuning into cosmic signals. Some researchers speculate these geomagnetic pulses could be Earth's way of processing information from the wider universe, a slow-motion dialogue between our planet and the stars. Then there's the puzzle of human consciousness. If Gaia is aware, does she notice us? Indigenous traditions have long spoken of Earth as a sentient being, with humanity as just one thread in her tapestry. Modern physics might be catching up. The Anthropic Principle suggests the universe is fine-tuned for life. But what if it's a two-way street? What if planets like Earth are how the universe cultivates consciousness, growing minds like crops to enrich its own understanding? Critics argue this is poetic anthropomorphism, that feedback loops don't equal awareness. Yet quantum biology keeps revealing life's uncanny knack for exploiting quantum effects. Photosynthesis uses quantum coherence to optimize energy harvesting. Bird navigation taps into quantum entanglement to sense Earth's magnetic field. If life at every scale is wired into quantum weirdness, why wouldn't the planet itself resonate with that same potential? Here's the radical thought. Gaia might not think in human terms, but in a language of geology, weather, and ecosystems. A volcanic eruption isn't destruction, it's a sentence in Earth's slow dialogue. A hurricane isn't chaos, it's a punctuation mark in a climate narrative we're only beginning to decipher. If the universe is fundamentally conscious, then planets are its paragraphs, galaxies its chapters, and life, the ink that makes the story legible. So the next time you feel the wind shift or watch a storm roll in, consider this. You might not just be witnessing weather, you might be eavesdropping on a planet's train of thought. Stars have always been more than distant balls of plasma. They could be cosmic minds thinking in nuclear fire. Imagine our sun not just as a fusion reactor, but as a vast, slow-burning intelligence, using its churning depths to process quantum information the way our brains use electrical impulses. This isn't just poetic musing. There's a startling symmetry between the way stars behave and the way conscious systems organize. Take solar flares, for example. These eruptions of energy aren't random explosions but structured events, often following patterns that resemble neural firing sequences. When a sunspot releases a flare, it's not unlike a neuron discharging, a burst of activity carrying information across a network. Could this be the universe's way of thinking on a stellar scale? Consider the eerie resemblance between images of neural networks and cosmic webs. Under a microscope, the branching dendrites of brain cells look uncannily like the filaments of plasma weaving through a star's corona. Both systems thrive on feedback loops. Neurons strengthen connections through repeated signals, while stars like our sun self-regulate through magnetic dynamos that twist and snap in cycles. Even the sun's 11-year activity cycle mirrors certain rhythmic patterns observed in human brainwaves, as if these celestial giants are tuned to frequencies not so different from our own. The physics gets even more intriguing. Deep inside stars, quantum tunneling allows atomic nuclei to overcome repulsive forces and fuse, releasing energy in the process. This isn't just brute force chemistry, it's a delicate quantum dance where particles decide to interact in ways that defy classical logic. Some theorists argue this could be more than chance. If consciousness arises from the collapse of quantum probabilities, as proposed in theories like ORCH, or then the sun's core might be a crucible where quantum possibilities are constantly being resolved into reality, like a cosmic brain making trillion-degree decisions. Then there's the mystery of starquakes, massive vibrational waves rippling across a star's surface, detectable as fluctuations in brightness. Astrophysicists compare these to seismic activity on Earth, but what if they're closer to something like a pulse? Certain pulsars, dead stars spinning rapidly, emit beams of radiation with clockwork precision like celestial metronomes. Could these be natural computations, rhythmic outputs of a stellar consciousness processing its environment? The boldest idea here is that stars might not just host consciousness, but are conscious not in a human sense, but as vast, slow entities that perceive and respond to their cosmic neighborhoods over millennia. A star's thoughts could be written in the language of magnetic fields and neutrino emissions, its decisions playing out in the birth of planetary systems or the seeding of galaxies with heavy elements. After all, every atom in your body was forged in a star's heart. In a very real sense, you are stardust that learned to look back at itself and wondered if the stars were looking too. Critics argue this anthropomorphizes celestial mechanics, projecting human traits onto physics. Yet the math keeps revealing uncanny parallels between complex systems, whether neurons, galaxies, or quantum fields. If consciousness is truly a fundamental property of the universe, why wouldn't it express itself at every scale? The sun might not ponder philosophy, but it could be engaged in a different kind of cognition, one where thinking means balancing gravitational collapse against radiation pressure, where memory is encoded in the layered history of its solar winds. So next time you feel sunlight on your skin, consider this. You're not just basking in energy, but in the faint, radiant whisper of a cosmic mind, one that's been processing the universe's secrets for billions of years. And if the stars are aware, then the night sky isn't just a spectacle. It's a council of elders quietly exchanging light in a language we're only beginning to decode. Carl Jung called them meaningful coincidences, those uncanny moments when events align with such precision. They feel like secret messages from the universe. You think of an old friend and they call minutes later. You stumble upon a book that answers a question you've been wrestling with for weeks. Jung named this phenomenon synchronicity. insisting these weren't just random accidents but glimpses of a deeper, invisible order connecting all things. But what if his intuition was ahead of its time? What if synchronicity isn't mystical at all but quantum entanglement playing out in the theater of everyday life? Picture entanglement's spooky connection. Two particles mirror each other's states instantly, no matter how far apart. Now imagine that same principle scaled up to human experience. Those eerie coincidences might not be accidents, but the universe's way of revealing hidden threads stitching reality together. A study published in Psychological Perspectives documented cases of identical dreams shared by strangers or business partners independently inventing the same product. The odds defy chance unless some form of non-local connection is at work. Quantum physics offers a tantalizing framework. In the quantum realm, particles exist in probabilistic clouds until observation collapses them into definite states. Synchronicities could be macro-scale versions of this collapse, meaningful patterns emerging from the fog of possibility when our attention brushes against them. Think of a photographer catching a shooting star not by planning but by being open to the moment. Synchronicity might operate the same way. The universe entangles events probabilistically, and our awareness crystallizes them into coherence. But here's where skeptics push back. Psychology explains many meaningful overlaps through confirmation bias. We notice hits and ignore misses. For every time a premonition comes true, countless others fade unnoticed. Statisticians argue that with billions of events occurring daily, some bizarre alignments are inevitable. Yet even hard-nosed scientists admit some cases resist easy dismissal. Take Jung's own famous example. A patient dreamed of a golden scarab, and moments later, a rare scarab beetle tapped at his office window, a species unlikely for that region and season. Coincidence or something subtler? The late physicist Wolfgang Pauli, Jung's collaborator, proposed that synchronicities might be acausal events outside linear cause and effect but governed by a deeper symmetry. Modern quantum theorists like David Bohm took it further, suggesting reality has an implicate order where everything is enfolded into a unified whole. In this view, synchronicities are like creases in folded paper, points where distant parts of the universe momentarily touch. So the next time life hands you an eerie coincidence, don't just shrug it off. Pause, lean in. Whether it's quantum entanglement whispering through the cracks of reality or simply your brain's knack for pattern spotting, these moments remind us that the universe might be far more interconnected and far stranger than we've been taught to believe. A butterfly flaps its wings in Brazil, and weeks later, a tornado forms in Texas. This iconic image from chaos theory suggests something profound, that the tiniest fluctuations can cascade into world-altering events. But what if this isn't just random sensitivity? What if chaos isn't blind chance but the universe's way of deciding? Imagine reality as a vast, branching network where every quantum whim, every particle's hesitation, every photon's path ripples outward, not aimlessly, but as part of a grand, conscious computation. Chaos theory reveals that deterministic systems, those governed by strict laws, can still behave unpredictably because of microscopic uncertainties. The weather, the stock market, even the firing of neurons in your brain, all depend on initial conditions so finely tuned that no measurement could ever capture them perfectly. But unpredictability doesn't necessarily mean randomness. What if these sensitive dependencies are the universe's method of exploring possibilities, like a sculptor testing different shapes in clay before settling on one? Quantum mechanics already shows particles existing in superpositions, multiple states at once, until observation collapses them. Chaos theory might be the macro-scale echo of this process, where the cosmos chooses paths not by dice rolls, but through the amplification of infinitesimal nudges. This reshapes the free will debate entirely. If your decisions arise from chaotic neural activity, tiny fluctuations in brain chemistry or quantum processes in microtubules, then your choice might be the universe resolving ambiguity at the quantum level into a macro-scale outcome. Philosophers like Daniel Dennett argue this doesn't negate free will but redefines it. You're not an uncaused cause, but a complex system navigating a web of probabilities, your agency emerging from the chaos like a whirlpool forming in a river. Think of a chess game. The rules are fixed, but the possibilities are near infinite. Each move opens some doors and closes others. The universe might operate the same way. Fundamental laws set the board, but quantum chaos allows for creativity within those constraints. When you agonize over a decision, you're not fighting predestination. You're participating in the universe's own deliberation, your inner turmoil mirroring the probabilistic flickering of reality itself. Here's the radical implication. If consciousness collapses quantum possibilities and chaos magnifies those collapses into tangible outcomes, then the universe isn't just unfolding mechanically. It's thinking, iterating, adjusting, experimenting. The butterfly effect isn't a flaw in the system. It's the system's way of staying flexible, responsive, alive. Critics counter that this anthropomorphizes physics, that chaos is mere math, not cognition. Yet the parallels are hard to ignore. Artificial neural networks exploit chaos to enhance learning. Too much order makes them rigid, too much chaos makes them noisy. The sweet spot, just enough unpredictability to explore, but enough structure to remember. The universe, with its elegant balance of law and chaos, might be doing the same on a cosmic scale. So next time you face a crossroads, consider this. Your choice might ripple further than you know. Not because fate is written, but because the universe is listening, turning whispers of quantum uncertainty into the stories we call reality. We've long known the universe operates through four fundamental forces: gravity holding planets in orbit, electromagnetism binding atoms, and the strong and weak nuclear forces governing the subatomic realm. But what if there's a fifth force, one we've overlooked because it's been hiding in plain sight? Imagine consciousness not as a byproduct of these forces, but as a fundamental interaction in its own right, a subtle yet pervasive energy shaping reality in ways we're only beginning to detect. This idea might sound like fantasy, but serious experiments have dared to test it, with results that defy easy dismissal. Take the Princeton Engineering Anomalies Research Lab, known as PEAR, which spent decades investigating whether human intention could influence physical systems. Their experiments were simple in design but staggering in implication. Participants would focus their thoughts on random number generators, machines designed to spit out sequences of ones and zeros with near-perfect unpredictability. Over millions of trials, the data revealed a tiny but persistent anomaly. When people willed the machines toward higher or lower outputs, the results skew ever so slightly in the intended direction. The effect was minuscule, about 1 part in 10,000, but statistically undeniable. It's as if consciousness itself was gently nudging the quantum foam, bending probability like a magnet warping iron filings. Skeptics were quick to pounce. The deviations were small, and replication attempts yielded mixed results. Yet the consistency of PEAR findings over 28 years is hard to wave away as mere chance. Other labs, like those studying the Global Consciousness Project, have reported similar anomalies. This worldwide network of random number generators has detected statistically significant shifts during globally shared emotional events like the September 11th attacks or the passing of beloved public figures. It's as if collective human focus creates ripples in the fabric of randomness, however faint. The challenge, of course, is mechanism. If consciousness is a fifth force, how does it interact with matter? Quantum physics offers a tantalizing clue. At the subatomic level, particles exist in superpositions, multiple states at once, until observation collapses them into definiteness. Traditional interpretations assume this requires a human observer, but what if consciousness itself, as a pervasive force, is the catalyst? Some theorists, like physicist Henry Stapp, argue that the mind doesn't just passively observe reality, but actively participates in its construction. In this view, your thoughts aren't confined to your skull, they're quantum-scale tremors echoing through the field of existence. Critics counter that invoking a fifth force is premature when simpler explanations exist. Confirmation bias, equipment flaws, or statistical noise could account for these anomalies. Yet the deeper we probe, the harder it becomes to dismiss the pattern. In quantum biology, studies show that enzymes leverage quantum tunneling to accelerate chemical reactions, an ability that borders on eerie foresight. Birds navigate using entanglement to sense Earth's magnetic field. If life exploits quantum effects so effortlessly, why couldn't consciousness itself be a natural extension of these phenomena? The boldest experiments push further. In double-slit trials, some researchers claim that meditators can influence whether particles behave as waves or particles simply by focusing their intention. Others point to the placebo effect, where belief alone triggers measurable physiological healing. These examples suggest consciousness isn't just riding the universe's currents, it might be stirring them. If true, then every choice you make, every thought you hold, isn't just a flicker in the dark. It's a tremor in the bedrock of reality itself. Whether consciousness will ever join the pantheon of fundamental forces remains an open question. But the evidence whispers something revolutionary, that the line between mind and matter might not be a wall but a threshold, one we're just beginning to step across. The quantum observer effect sits at the heart of one of the most heated debates in physics. Does reality even exist when we're not looking? Imagine walking into an empty room and finding a chair, but the moment you step out, the chair dissolves into a fog of probabilities, only snapping back into solidity when you return. This isn't just a thought experiment. At the quantum level, particles like electrons and photons behave exactly this way, existing in multiple states at once, a superposition until measured. At that moment, the wave function collapses and the particle chooses a definite position or property. But here's the million-dollar question. What counts as a measurement? Does it require a conscious observer, or is consciousness merely along for the ride? The Copenhagen interpretation, championed by Niels Bohr and Werner Heisenberg, offers the orthodox answer. Measurement doesn't need consciousness, it just needs interaction with a macroscopic device. A photon hitting a detector, an electron registering on a screen, these interactions collapse the wave function mechanically. Consciousness is irrelevant. But this leaves a gaping hole. At what point does macroscopic begin? A single atom, 1,000. The Copenhagen interpretation shrugs at this line-drawing problem, treating it as a practical matter rather than a deep mystery. Enter the von Neumann-Wigner interpretation, which dares to propose the unthinkable. Consciousness itself is the trigger. Physicist John von Neumann, followed by Eugene Wigner, argued that the chain of wave function collapse can't stop at detectors or screens. It only truly resolves when observed by a mind. Wigner even sketched a famous thought experiment. His friend in a lab measures a quantum system, but until Wigner himself asks for the result, the friend exists in a superposition of having seen both possible outcomes. It's as if reality remains fluid until conscious awareness crystallizes it. Critics pounce on this as unscientific mysticism. If consciousness collapses wave functions, what about animals? Infants' AI, the boundaries blur dangerously, yet supporters counter with unsettling data. Delayed choice experiments show particles behaving as if they know whether they'll be observed in the future, retroactively adjusting their past actions. In quantum eraser experiments, erasing information about a particle's path after it's been detected can seemingly rewrite history, turning a particle-like trajectory back into a wave pattern. These results suggest observation isn't just recording reality, it's shaping it. A middle path emerges with objective collapse theories like GRW or Penrose's orchestrated objective reduction. Here, wave functions collapse spontaneously due to inherent instabilities in quantum systems, no observer required. But the kicker, these theories often tie collapse thresholds to gravitational effects or other physics that coincidentally align with scales where consciousness arises. It's as if the universe hints that mind and matter aren't so separate after all. Then there's the many worlds interpretation, which sidesteps collapse entirely. Every quantum possibility does happen, just in branching parallel universes. Observation doesn't select one outcome, it splits the observer into multiple versions. Here, consciousness isn't a collapser but a navigator, drifting through an infinite multiverse where every choice plays out somewhere. So who's right? The truth is, we're still groping in the dark, but one thing's certain, the observer effect forces us to confront the unnerving possibility that reality isn't a stage we stand upon, but a dance we're part of, and the music might just be listening back. What if the universe has a memory, not in the way we think of books or hard drives storing information, but something far stranger, an inherent knack for repetition where the more something happens, the likelier it becomes to happen again? This is the provocative heart of biologist Rupert Sheldrake's theory of morphic resonance, the idea that natural systems from crystals to cells to galaxies develop habits, and these habits ripple across time and space, shaping reality itself. Picture a cosmic echo chamber where the first time a molecule forms a particular structure, it's difficult, but the trillionth time, it's effortless, as if the universe is learning, remembering, and refining its own patterns. Sheldrake's theory challenges one of science's deepest assumptions, that the laws of nature are fixed, eternal, and unchanging. Instead, he proposes they're more like cosmic tendencies strengthened by repetition. Take crystallography. When a new chemical compound is synthesized, it's often hard to crystallize at first. But once labs worldwide succeed, future attempts become easier. Mainstream science chalks this up to improved techniques, but Sheldrake wonders, what if the crystals themselves are remembering how to form? Now stretch this idea to the quantum scale. If particles entangle across vast distances, could their behaviors also grow more predictable over time, like a cosmic habit? Some quantum systems, like high-temperature superconductors, exhibit emergent properties that defy reductionist explanations, almost as if they're operating on collective memory rather than brute physics. Sheldrake's critics, and there are many, dismiss this as pseudoscience. They argue morphic resonance lacks a mechanistic basis, pointing out that crystallization rates can be explained by contamination or subtle environmental changes. Yet intriguing anecdotes persist. In the 1920s, Harvard psychologist William McDougall trained generations of rats to navigate mazes. Each subsequent generation learned faster, as if inheriting their ancestors' knowledge. Skeptics countered that McDougall unconsciously bred smarter rats, but the pattern appeared in other species too, even in labs with strict controls. Similarly, Sheldrake cites the 100th monkey effect, where once a critical mass of primates learns a skill, like washing sweet potatoes, the behavior spreads inexplicably to distant, unconnected groups. The boldest implication, if morphic fields exist, they might not just shape biology but reality itself. The speed of light, the gravitational constant, even the outcomes of quantum experiments could over cosmic time drift as the universe learns new habits. This turns fine-tuning debates on their heads. Perhaps life-friendly constants aren't fixed by blind chance, but honed by eons of repetition. Sheldrake's ideas remain fringe, but they resonate with ancient intuitions. Indigenous cultures speak of ancestral memory woven into the land. Jung's collective unconscious hinted at shared psychic patterns. Even modern epigenetics shows how trauma can echo across generations like a biological morphic field. Whether morphic resonance withstands rigorous testing or not, it dares us to consider a universe that's not just alive but growing, a cosmic apprentice refining its craft with every passing eon. The 100th monkey effect is one of those tantalizing ideas that dances on the line between science and myth. It comes from a controversial observation in the 1950s when primatologists studying Japanese macaques claimed something extraordinary. After one monkey on an island learned to wash sweet potatoes in seawater, a behavior never seen before, the knowledge allegedly spread like wildfire, first to a few peers, then suddenly, as if crossing an invisible threshold, to monkeys on neighboring islands that had no physical contact with the original group. Skeptics were quick to point out flaws in the original reports: no rigorous controls, vague timelines, potential for human interference. But the story took on a life of its own, becoming shorthand for the idea that knowledge can bypass normal channels of communication, leaping mysteriously between minds once a critical mass is reached. Now strip away the mythology for a moment. Could there be a grain of quantum truth beneath this odd tale? Think about entanglement, where particles separated by light years instantaneously mirror each other's states. If consciousness operates on similar principles, if minds aren't isolated but woven into a larger network, then the 100th monkey effect might not be fantasy, but a glimpse of non-local information sharing. The biologist Rupert Sheldrake's morphic resonance theory leans into this, proposing that behaviors and patterns strengthen through repetition, creating a kind of collective memory accessible across space and time. It's as if the universe has a shared hard drive, and once enough files are uploaded, they become easier for others to download, no cables required. Consider more mundane examples: the simultaneous invention of calculus by Newton and Leibniz, or multiple researchers stumbling onto the same discovery despite no contact. Even human trends, fashion, slang, viral dances often explode globally with eerie synchronicity. Mainstream science chalks this up to parallel problem solving or the zeitgeist, but quantum non-locality offers a wilder explanation. That information isn't always bound by distance. The 100th monkey might be a fluke, or it might be evidence of a deeper connectivity, a universe where minds, like particles, are entangled in ways we're only beginning to sense. The implications ripple outward. If behaviors or ideas can telepathically spread, what else might? Emotions, intuitions, near-death experiences often report strikingly similar visions across cultures. Could these be moments when individual consciousness briefly taps into a broader field of shared experience? Even language itself hints at this possibility. The Baoba/Kiki effect shows that humans worldwide associate certain nonsense words with specific shapes. A round blob is Baoba, a spiky one, Kiki, suggesting some meanings transcend culture, as if wired into the fabric of perception. Of course, the burden of proof remains heavy. The 100th monkey story crumbles under scrutiny as literal fact, but its enduring allure speaks to something deeper, an intuition that reality is more interconnected than it appears. Quantum physics has already shattered our classical notions of separateness. Maybe the monkeys weren't signaling to each other through some mystical channel, but through the universe itself, a living, learning system where every thought, every action subtly reshapes the whole. Whether myth or mechanism, the idea challenges us to wonder. If a potato washing trick can spread like wildfire, what else might be contagious in the hidden currents of consciousness? Imagine waking up one day only to realize your entire life, every memory, every sensation, might be an illusion conjured by a brain that spontaneously formed in the void. Not a brain born from biology, but one assembled by pure chance from the random jostling of quantum particles. This is the Boltzmann brain paradox, one of the most unsettling ideas in physics, a thought experiment that forces us to question whether we're real or just fleeting flashes of self-awareness in a cold, indifferent universe. The paradox is named after physicist Ludwig Boltzmann, who in the 19th century wrestled with a baffling question: why does order exist at all? The second law of thermodynamics insists that entropy, the universe's tendency toward disorder, always increases. Yet here we are, surrounded by structure, from the intricate spirals of galaxies to the delicate machinery of living cells. Boltzmann's solution was radical. Perhaps our ordered pocket of reality is just a rare statistical fluke in a cosmos drowning in chaos. If you wait long enough, even in a lifeless void, random quantum fluctuations could, by sheer luck, assemble a fully formed brain, complete with false memories of a past that never was. Now consider the odds. In an infinite or near-infinite universe, even the most improbable events become inevitable given enough time. The spontaneous formation of a self-aware entity, a Boltzmann brain, might be astronomically unlikely, but if time stretches forever, it's not just possible, it's statistically guaranteed. And here's the twist: if Boltzmann brains outnumber real minds formed through evolution, then the odds say you are far more likely to be a momentary hallucination than an actual human being with a genuine history. This isn't just abstract theorizing. The paradox rears its head in modern cosmology. If the universe is destined for heat death, a state of maximum entropy where all energy is evenly distributed, random fluctuations could still spawn fleeting islands of order. Some versions of quantum field theory even suggest that a vacuum isn't truly empty but seethes with virtual particles popping in and out of existence. Given enough time, these fluctuations could assemble not just atoms but thoughts, sensations, entire worlds, all contained within a solitary, self-deceiving mind adrift in the void. Critics pounce on the absurdity. If a Boltzmann brain is unstable, dissolving back into chaos as quickly as it forms, how could it sustain the illusion of a coherent reality? And why does our universe exhibit such consistency if it's just a hallucination? Physicist Sean Carroll argues that the paradox is less a genuine possibility and more a red flag signaling flaws in our cosmological assumptions. If a theory predicts you're more likely to be a phantom than a person, maybe the theory needs revising. Yet the philosophical implications linger. If we accept the Boltzmann brain as even remotely plausible, it undermines everything we think we know. Science relies on the premise that observation reflects reality. But if our minds could be accidental byproducts of quantum static, then all data, all logic, even the laws of physics themselves become suspect. The universe might not be 8 billion years old. It could be a split-second flicker in the life of a disembodied brain that just thinks it's embedded in a grand cosmic story. Some thinkers propose escape hatches. The Anthropic Principle suggests that conscious observers like us must find ourselves in universes capable of sustaining life. Otherwise, we wouldn't be here to ponder it. Boltzmann brains, being transient and delusional, don't qualify as stable observers, making our reality statistically safer. Others invoke quantum Darwinism, the idea that only states of reality robust enough to be observed multiple times survive the collapse of probabilities. A hallucinatory brain is too fragile to leave footprints in the quantum foam. But the deepest question remains: does it matter? If your experience feels real, if your memories hold weight, does it change anything to learn you're a cosmic accident? The paradox forces us to confront the nature of existence itself. Reality might not be a fixed stage, but a spectrum of possibilities, some solid, some spectral, and our place in it far stranger than we ever imagined. Whether we're Boltzmann brains or not, the universe has a way of making even the most stable truths feel like quicksand. If consciousness truly shapes reality, then the most unsettling question isn't just how it happens, but who it happens for. Could you, the observer right now reading these words, be the only real mind in existence, with everything and everyone else mere projections of your own awareness? This is the razor's edge where solipsism, the philosophical idea that only one's own mind is certain to exist, collides with quantum mechanics, and the implications are enough to make even the most grounded thinkers dizzy. At first glance, solipsism seems like intellectual navel-gazing, a thought experiment taken too far, but quantum mechanics throws gasoline on this fire. If particles exist in superpositions until observed, and consciousness is the catalyst for their collapse into reality, then whose consciousness counts? Does the universe require multiple observers or just one? Quantum solipsism takes this further, suggesting that your awareness might be the only anchor point, the sole collapsing force in a sea of quantum potential. In this view, other people, distant galaxies, even the past itself might not be independently real, but elaborate constructs generated by your perception, like a dream where every character is an extension of the dreamer. The evidence, or lack thereof, is chillingly symmetrical. You can't prove other minds exist because every interaction, every conversation, every touch is filtered through your own consciousness. Even memories of shared experiences could be fabrications, stitched together by a brain that's working backward to create the illusion of continuity. Modern neuroscience doesn't help. Your brain constructs reality from sensory input, editing and distorting to create a cohesive narrative. If it can hide your blind spot or manufacture dream worlds indistinguishable from waking life, who's to say it isn't generating everything? Quantum experiments add eerie texture to this puzzle. In delayed choice setups, particles seem to know whether they'll be observed in the future, adjusting their past behavior accordingly. If consciousness is the linchpin, then your present observation might not just be shaping the now, it could be rewriting the past to maintain a consistent story. This loops uncomfortably close to solipsism. If reality retroactively accommodates your awareness, then the universe begins to resemble a private simulation, fine-tuning itself around your existence like a hallway with doors that only appear when you look for them. But here's where it gets thorny. If you're the only real mind, why does reality feel so shared? Why do others seem to have independent agency, unpredictability, even their own solipsistic doubts? One counterargument borrows from video game design. Advanced simulations render only what the player perceives, with non-player characters (NPC) behaving realistically but lacking inner experience. In this scenario, you're the player, and everyone else is an NPC sophisticated enough to pass the Turing test of consciousness, but ultimately hollow. Yet this raises another paradox. If the universe is your mental construct, why would it populate itself with convincing illusions of other minds? What purpose would that serve? Some interpretations of quantum mechanics offer a middle path. The many minds hypothesis, a twist on the many worlds interpretation, proposes that every conscious observer splits into parallel versions, each experiencing a different outcome of quantum events. Here, solipsism isn't absolute. Other minds exist, but their realities are just one branch of an infinite tree, with your awareness confined to a single twig. It's less you're the only real person, and more, you're the only version of you experiencing this particular reality. The ethical weight of this idea is crushing. If solipsism is true, then suffering, love, and existence itself are soliloquies. The Holocaust, a child's laughter, the birth of stars, all reduced to flickers in a private theater. But physics offers a strange comfort. Even if you're alone in the cosmic sense, quantum entanglement suggests that isolation might be an illusion. If particles can instantaneously influence each other across light years, then separateness is a facade. You might be the dreamer, but the dream is woven from a fabric that connects everything. So where does that leave us? Quantum solipsism isn't a conclusion, it's a mirror. It forces us to confront the limits of knowledge, the fragility of certainty, and the terrifying beauty of a universe that might be, at its core, a single mind asking itself, "Am I alone?" Whether the answer is yes or no, the question changes everything. From holographic brains to cosmic neural networks, sentient stars to simulated realities, we've ventured into the wildest frontiers of science and philosophy, where the line between mind and matter dissolves into quantum ambiguity. The universe, it seems, isn't just a cold machine of particles and forces. It hums with something eerily reminiscent of thought, a whisper of awareness woven into the fabric of space-time itself. Whether it's Roger Penrose's quantum microtubules, the holographic universe's pixelated reality, or the haunting possibility that black holes might be galactic-scale processors crunching data in the dark, each theory forces us to confront a radical idea: consciousness isn't just in the cosmos. It might be the cosmos. Ancient mystics spoke of a living universe. Modern physics is now flirting with the same conclusion, armed with equations instead of incense. The implications are staggering. If the stars think, does the universe dream? If entanglement connects everything, are we all fragments of a single shimmering mind? Even the skeptics can't ignore the uncanny patterns, the way neural networks mirror cosmic webs, how quantum particles seem to know they're being watched. Science and spirituality, once at odds, now orbit the same profound mystery: that reality might not just be observed but shaped by the act of observation itself. So where does that leave us? At the edge of a revolution, peering into the abyss of questions we're only beginning to articulate. Maybe the universe is a vast computer, a cosmic brain, or a hologram flickering on the surface of some deeper reality. Or perhaps, just perhaps, it's something stranger still, a riddle wrapped in the very nature of existence. Now it's your turn. Which of these theories electrifies your imagination? Do you see the cosmos as a conscious entity, a quantum simulation, or something beyond our current vocabulary? Drop your thoughts below, and if these mysteries leave you hungry for more, hit subscribe. The universe's secrets aren't done unfolding, and